Okay, hello everybody. So this is Casey Lee Live Software Edition for those who are new to this. So this has been something that's been going on for the last 3 weeks. Definitely going to try to continue it every week. And again, if you guys are new to this is really kind of software engineering, computer science, software development, kind of topics that we're covering here. And the format of this is usually kind of a formal lecture combined with a kind of Q&A session at the end. And really, this all kind of started with a general Q&A. So really the Q&A was really meant for anything. Like you could ask anything that was related to software stuff, web development stuff, desktop development, mobile development, whatever, any kind of software development really. Or even kind of startup related. My experience is a little bit starting up. I've started up a small business about 7 years ago, and I've been keeping it going. So really, it's anything like that. And the first part of these videos again is the kind of formal lecture. So it seems like the people who have been joining do enjoy the formal lectures in the beginning, and so we kind of amp that up a little bit. And the topics that we cover in those formal lectures really is driven a little bit by the audience. So if you guys have any suggestions, you can follow me on Twitter. You can see my Twitter handle right there. You can also chat on this here, to ask any questions, but also suggest topics for the future. So, the obviously the intent was to kind of get into live streaming in general. I saw other people doing live streaming, obviously, during this time where everybody's self-isolating and stuff. And also the fact that I know a lot of students that I interact with that at University of Ottawa, definitely got some benefit out of kind of some of these lectures. So we kind of try to keep that going as much as we can. So definitely spread the word if you can to other people who might benefit from learning some of these software topics. Again, it is kind of targeted at people who want to get into software development. So it is a little bit on the technical side, but I'm the first to say that anybody can learn this stuff. Anybody can learn this stuff. So everybody's welcome. So definitely spread the word. If you're new to kind of YouTube live streams and YouTube channels, be sure to subscribe to my channel. There's a little subscribe button. Hit subscribe, and when you hit subscribe, there'll be a bell icon next to it, and that's for notifications. So if you hit that bell icon, you'll be notified anytime I'm about to go on air. Now, again, for the software edition, this is generally Thursdays at 8 p.m. Eastern time. But again, that may change over time, and definitely be sure to be notified there. The other thing is, if you guys can't make it to the 8 p.m. live stream, yes, you'll miss out on the live conversation, and you'll miss out on your ability to chat and ask me questions and stuff like that. But these end up recorded at the end. So when the live stream is done, in a matter of 5 to 10 minutes afterwards, it's live. Sorry, I shouldn't say live. It is posted on YouTube. And you can watch from there. So if you're, I know some people had an exam tonight or are studying for exams, obviously right now, and they can't watch it right now. But you can always watch it afterwards. So definitely would appreciate the support anyway you can get it. And if you guys get benefit from this, and again, in terms of the conversation, feel free to tweet at me at KCD23 from there. So we're just waiting on a couple people. Looks like a relatively low turnout tonight so far. There might be some more people. But we'll just give a little bit of time there before we jump right into it. But today we are covering SQL databases. If you're doing an undergrad, I know at the University of Ottawa for sure, I believe their SQL database course is not until around third year. So this will be very beneficial if people want to get a head start on SQL databases. But this is really good if anybody who hasn't learned SQL databases yet. It's a really good way to understand how a lot of applications work in the world. So understanding SQL databases is a very important topic. Now, it's by no means the only way to do databases, and it's not the only way to store data persistently. There are new ways coming out, and there are definitely some technologies that are kind of starting to do away with the kind of traditional SQL database, but it is still very much a relevant topic today, and will probably be for quite a while, actually. Again, it's not something that you absolutely need to build certain applications, like mobile applications and web applications and things like that, but it is a very good piece of knowledge to have. And in fact, there's a lot of competing technologies out there, the big one being literally called NoSQL databases. NoSQL databases, I know myself, when I'm learning NoSQL databases, a lot of times I learn it from the perspective of a SQL database. Google released Google released all these videos about their NoSQL databases in Firebase, and they have this whole set of videos of if you're coming from a SQL background. And that's because a lot of software engineers and computer scientists and developers, a lot of those guys and girls came from a SQL background, at least nowadays, because SQL again is still around, and it's still kind of a very, very important topic. So that's what we're going to be covering today is SQL databases. So if there are any questions before we get started, feel free to ask. Again, we're just going to wait maybe a couple more minutes to see if anybody else joins, but then we'll get going after that. So again, don't forget to subscribe. Don't forget to hit that bell icon. And again, if you have any questions, feel free to type them in there, and I'll get them when I can. So we'll just wait for a couple more minutes. So. One of the other things I should mention that sometimes I forget to mention is that I'm live streaming this from my laptop. My laptop is an old 2015 MacBook, and the software that I'm using, OBS, Open Broadcast Software, which is an amazing piece of software, and it's free, and I believe it's open source. It's really awesome. The one thing about it is that it does tend to crash every now and then. So if the feed drops out for whatever reason, just hang tight. I just need to restart the program. I'll be back. I'll be back very shortly after that. So. Okay, why don't we just get into it, and we'll just see how things go. Okay, so I'll just start the presentation up here. So again, those who are new to this, again, we start off the kind of night with kind of, again, a formal lecture, and then we do some Q&A at the end. Now, I will say today's lecture is probably a little bit on the longer side. There's a lot to cover here tonight, especially if you're brand new to SQL databases. And the other thing to know is that there is a lot more to learn beyond this. There is a lot to deal with SQL databases that is way beyond this. So I just want to be clear that tonight is all about an introduction to SQL databases. There are definitely some things we're going to do that are going to be shortcuts, and there are definitely some things that I mentioned in here that are not the full picture. I will introduce you to some SQL statements. You'll find out what those are all about, and I'll be only showing you a little short piece of it. If tonight goes well and people really like it, what we'll probably do is we'll maybe do an intermediate or advanced lecture about SQL databases. But as it stands right now, we'll just do a little introduction, as there is a lot to cover here. And again, we'll see how things go after that. So, okay, so introduction to SQL databases. So let's start off with the basic question of what is a database. I know when I went through, software engineering in undergrad, there'd be a lot of terms that were tossed around that I didn't really fully understand. I kind of had a vague idea about, and it really took a long time before somebody just told me exactly what it is that we're dealing with. So that's the first question we're going to ask here. Like, what is a database? You guys might have been programming, applications, maybe a web application, maybe a desktop application, something in Python or Java or something. And you might have heard this term database tossed around, but not known exactly what it is. Okay, so it all starts with your application that you're building. Okay, so a lot of times when you start off in programming, you may, again, learn a language like Python, or you might learn a language like Java or C# or something like that, and you'll make a program, right? You'll code a program, and you'll run this program. And usually that program will have like a bunch of variables in it, and maybe sometimes it grabs some input from the user and says, oh, can you type in two numbers, and I'll add them up, or I'll multiply them. Or maybe you'll have somebody, type in their name, and then you'll say hello back to them or something like that, right? That's kind of usually the introductory programs that you learn when you start getting going in programming, right? And after that, you might learn some cool object-oriented principles where you can like store a bunch of data in kind of an encapsulated object, right? So you might have a person object, and that person object has a name and a birthday and a hair color and an eye color. You might do something like student and courses, and you have a course object and all these things. And you program these things, and they're very impressive programs, and they get very big, and you get all these like lines and lines of code and multiple files and stuff like that. But usually when you're starting in programming, one of the biggest things I remember I had an issue with is that as soon as I'd stop the program, any data that I was dealing with or interacting with was just gone after that point. Like if I basically ran a Java program, I would get to interact with it and everything like that, and then as soon as I would like stop it, all that data was gone, right? I had no semblance of that data. And this is true for any kind of program that you write. A lot of the programs that you start off with, as soon as the program is done or you shut off the computer or whatever, the program is just done, right? And for a lot of applications, this is actually okay. Like for example, if you fire up the calculator application on your desktop, you usually don't save what you last entered in there. I mean, maybe some of the more sophisticated ones, that's okay. But a lot of times you don't save what's on there. But then you look at most of the applications that you interact with. If you think about some of the desktop applications you interact with, say like Microsoft Word or Adobe Photoshop or something like that, you definitely have this idea where you work on something and then you save it. And then if you turn off your computer and turn it back on, that saved data still exists. It's not gone. It's not like when you close down Microsoft Word, you lose the work, right? You save it, right? And so I remember always asking myself the question, like, when are we going to get to that point where we can save stuff, right? And one of the most common ways that we interact with desktop applications especially is this idea that we save it to some persistent place, okay? And persistent just means it persists past the life of the application, right? So if the application is shut down or you turn off the computer, the data is stored persistently. And again, a lot of desktop applications do this with a file, right? So Microsoft Word, for example, when you save your data, you save it to a file, right? If you're using Adobe Photoshop, you save it to a PSD file, right? And so a lot of the applications that we deal with, when we're growing up and we're learning to use computers for the first time, they write to a file, right? And that file usually lives on your computer, right? So that's one way of storing information persistently. And to be honest, you can do this. Like if you write a Java application or a Python application or whatever, you can decide to store that information. Like say someone types in their name, you can write that information to a file and save it to a file, and then it's persistent. And then when you launch up the application, you may read that file again or whatever, right? So that's one way to store data persistently, is in a file. Now, this is all well and good, but there's a whole other set of applications that don't actually store their information on a file. And typically we don't interact with these applications directly on our desktop. A really good example of this is web applications. Okay, now web applications, if you were to strip down, some of the web applications you use to their very bare basics. So if you look at like Facebook or even like Gmail or what else, like Airbnb or something, right? You will sign up for an account and you store your first name and your last name and your email and your password and stuff like that. And over on their side, they store their information somewhere, right? And while so over there, they're going to store their information somewhere. And normally what these applications do is they store it in something we call a database. Okay. Now, in a couple slides, you'll learn that ultimately a database probably in the very end, like after kind of explaining this, it ultimately is just a file. But we'll get to that in a second. So another way to store your data is in what we call a database. Okay. So one thing I should note is that when we talk about databases, a lot of times in diagrams, we represent them with a cylinder. So I'm just going to change that icon right now. So this is usually how we talk about it. So when you're writing an application and you want to store something persistently, you could store it in something called a database. All right. And so at its very bare basic minimum, what a database is basically a way to persistently store data. Okay, that's really the definition, like the easiest definition of a database. Okay, is that it's a way to store data, okay, persistently. All right, so that when you shut it down, come back up, it's still there. Okay. Now, one thing I should mention is there are databases that exist out there that don't have this idea of persistent storage, but for today's lecture, being an introduction to it, let's just kind of go with it for now. Okay. So at its simplest, a database is a way to persistently store data. But there is one extra piece to this that really qualifies something as a database. Like you could store data somewhere persistently, and that's not the end all be all of it. One of the very important things about a database is that there is an intelligent way to read that data and to write that data. Okay? So, I mean, if you think about storing, say, a person's name and an age and something like that, you might decide to just store it in a file and just write the name and the integer and all that stuff like that. And you might not know how to do that today, but I mean, there are libraries where you can just write to a file and just write text. And you might write all this text plainly in there. And you just kind of just dump it in that file. And that may not be a really intelligent way, because what if you now need to go and find the specific age of that person or the specific name of that person? Or what if you have like 100 people on that list and you want to go find specifically the person named Mike, what his age is or whatever, right? If you just kind of store it all kind of hodgepodge or whatever and just kind of dump it to a file, that's not really an intelligent way to do it. Databases are typically characterized that they have some intelligent way to read that data and write that data. Whether it be a quick, efficient way to do it, whether it be a way to find exactly what you need, there's some intelligence behind the way that you actually read the data and that you write the data. Okay? So one more time. For our intents and purposes, what a database is a place to store your data that has some intelligent way to read and write to. Okay? So that's what a database is. Okay, so what do the internals of a database look like? How does a database actually work? Okay. Now, this again is going to be a little bit of a simplified diagram, but I think it'll help in terms of understanding how a database works. Okay. So this is the diagram we had before when an application is going to read or write to a database, right? This is kind of the high level view of when I write an application and I want to store data, I'm going to store it in a database. Okay. Now, databases come in a lot of different flavors and databases come in a lot of different forms, and there's a lot of ways to view a database if you just look at it that definition. Okay. For today's intents and purposes, this is what it looks like. Okay. A database, a lot of times, is hosted on a database server. Okay. So what is a database server? Well, a database server is actually two things. If you go back to my last lecture about web servers, it's kind of the same thing, how a web server is two things. A web server is the physical machine that a web development code is running on. And then the little program that's running on that machine to listen for web requests and responses is called a web server. So those are two things called a web server. Same thing here with a database server. A database server is the machine that's actually running a program. And that little program that's running on that machine that's listening for read and write requests is called a database server. Okay. And by the way, this machine can be anywhere on the internet. It can be on the network. It can be on the same machine as the application you're running. And usually when you develop applications that talk to a database, you usually start with the machine, like the database is sitting on your machine directly. Okay. So the database is really behind this database server. And so you're going to be sending read and write requests, not directly to the database, but you're going to send it through the database server, and the server is going to interact with the database. Okay. Now, that database server, the reason it's called a server, it serves multiple databases. Okay. And it can be in any number of databases. You could have 100 databases on the same database server. Okay. You could have as many as you want. And typically, again, if you missed my lecture last week, typically any application that you build would have its own database. It's not entirely out of the realm of logic, but it's really weird sometimes when you have multiple applications not sharing the same tables, but having the data on the same database. So if you have one application that is like dealing with, I don't know, courses and teachers, and then you have another application that's dealing with like short-term rentals, like Airbnb, and let's say the applications have nothing to do with each other. It would be really weird to store all that data in the same database. And typically, you would have a database for each of those applications, and that's why you have multiple databases. Okay, and as you work on your projects, as long as those projects have nothing to do with each other, you would have a different database for each one of those applications. Okay, so they're all hosted on this database server, and your application can send read and write requests to that database. Okay. Now, one thing I should mention is that this cylinder, these cylinders, this idea of a database is a little bit of an abstract concept. And concretely, and I don't know this 100% because I didn't write these database servers, but you can see it because you specify this in a configuration. But these databases ultimately get written to a file, okay? So my very first diagram of like an application writing to a file, it's kind of really the same thing here. Okay. Ultimately, you're writing to a file. All right. There's a data file that sits in there. Okay. But the reason I don't really show it that way is because when you're dealing with databases, you don't typically think about that writing to the file. You don't deal with the file directly. You're not the person writing to the file. You really think about dealing with the database itself, and the database server writes to the file. Okay. But I don't want to lie about it and say you're not writing to a file. Ultimately, in the end, there is a file that sits there. Okay. So that's really how the internals of a database work. So you have databases that sit on a server. You have an application that can read or write to those databases. And in the background, again, that we don't concern ourselves with, the database server is ultimately writing and reading that data from a file. Okay. So, like I said, when we deal with database servers, we don't usually care about the internals of how the database gets its data. Okay. And we don't really care about that part to the file. Okay. What we usually care about is we just think about it abstractly as we're interacting with a database, and the database server will do the rest. Okay. So really, this is the part we care about. Okay, when we write an application, we just care about the reading and writing to one of these databases. We don't care about this part below down here. Okay. So what is a SQL database? Okay, if that's how a database typically works, what is a SQL database? A SQL database is basically a database where you use a language called the SQL query language to perform your read and your writes. Okay, so let's go back. So I said that when we're application developers, we read and write to a database server. If that database server is a SQL database, then it accepts SQL query language to execute the read and the writes. That's what a SQL database is. Okay, and if you're ever wondering what SQL stands for, it's one of these like cyclical acronyms. It stands for SQL Query Language. That's what SQL stands for. Okay. So that's what a SQL database is. A SQL database is exactly what I showed you, but it uses the SQL Query Language in between here. That's what a SQL database is. Okay. So there's a lot to swallow there. Let's just rewind a little bit. When you're developing applications, you will inevitably want to store data persistently somewhere. Okay. An intelligent way to store that data is in a database. One type of database is called a SQL database. And SQL databases use the SQL query language to execute read and writes from the database, to and from the database. Okay? Okay, so that's what a SQL database is. Okay? I'm going to pause there for a second and just say that if you guys watching have any questions during this, do not be afraid to ask in the chat. Okay, I'll try to monitor the chat as much as I can. Don't be afraid to ask questions if you have any questions about what I just said there. Okay, but if all that makes sense, let's move on. So you know what a SQL database is. I already mentioned that SQL is a type of database, and there are many types of databases out there. Okay. Even in SQL, though, SQL itself is just a standard that a bunch of vendors out there can decide to implement. Okay. And in fact, a lot of different people make SQL databases. Okay. Microsoft makes one, and they call it Microsoft SQL Server. Oracle makes a database. I think it's just literally called Oracle, and it's a SQL database. There is an open source community called PostgreSQL. Okay, and that is a SQL database called PostgreSQL. There's an open source community called MySQL. They're also open source and free. And SQLite is another database, actually. And all of these databases have the same basic SQL query language. Okay, so if you know how to write queries against a Microsoft SQL Server database, a good chunk of what you know from that, you'll be able to apply to PostgreSQL, you'll be able to apply to MySQL, and so on. Okay, so the majority of the SQL query language that you'll be writing will be the same across all these SQL databases, and that's why they're called SQL databases, because they use this SQL standard. Okay. Now, what differs between these, though, you have to be a little bit careful about. Okay, each one of these, yes, supports the standard SQL query language, but each of them also has some custom functionality. Okay, like for example, they may add some added functionality to like uppercase or lowercase your characters, or to do some complex math equations. So each one of these has their own set of kind of custom functionality. So you have to be a little bit careful. Now, again, when you're just starting to learn SQL, most of the stuff you'll learn will be compatible across all these databases. So if you are working on a project that uses a MySQL database versus a SQL Server, like Microsoft SQL Server database, you don't have to worry, because most of the queries that you guys write will probably be the exact same across the board. But you have to be a little bit careful when you go from one to the other, because there may be like little things here and there that might be different. Okay, but for the most part, you can consider them the same. And in fact, one thing I should also mention is that not all of these adopt the exact same kind of server architecture that I just described. Okay, most of them, again, if you're just learning this, it's the best way to go about it. But some of them don't even have a server. SQLite is a good example of this, actually. SQLite was the first SQL database I ran into that I didn't realize there's no server in between. You're not interacting with a server. You actually end up interacting directly with the file itself. So just a little heads up on that, okay? Okay. So now we know what a SQL database is. We know there are multiple out there. We understand the general concept that if we want to store data, we're going to read and write to a SQL database. Let's actually see this in action. And how would you get this up and running? Okay, so like if you're brand new to this and you're like, oh, this seems all really great, what do I need to do to actually start doing this on my computer? Okay, so there's really 5 steps. Okay, the first step is you need to set up your SQL server. Okay, you need to set up your SQL database server. Okay, so again, this is a program that runs on your machine that's waiting for requests to read and write to a database. Okay, so what that means basically is going onto one of these websites like MySQL or PostgreSQL or whatever, and looking for an installer to install that onto your machine. Okay, so we're in this tutorial, by the way, we're going to use PostgreSQL. That's the vendor we're going to use. And so what you want to do is look for how to install PostgreSQL. Okay. Now that it's installed on your machine and up and running, okay, again, this thing is just running in the background. The second step is you want to actually connect to that server. Okay. Now, I'll talk about how we connect to that server in a bit, but we're going to use some application to connect to that server. Okay. Third, we are going to create a database on that server. Okay. Remember, I said the database server can have multiple databases. We're going to create a database that we're going to use. Step 4, after the database is created, we're going to connect to that database. And then finally, step 5, which is what the majority of this lecture is we're going to execute SQL queries to read and write data. Okay, so let's dissect each of these steps individually. Okay, step 1, set up your SQL server. Okay, we're not going to cover this today, but basically what you're going to do is you're going to install this, you're going to install the database vendor that you want to install. Okay, so if you went here and you just like search for, say, PostgreSQL. Okay, You can see it here, and you can see there are multiple ways to install it, okay? So here are the latest releases. You can download them, and you can read the documentation on how to actually install it, okay? I haven't used MySQL, but it's probably very similar. Okay, so here's MySQL. There are definitely ways to install it. Now, one thing to know about MySQL and PostgreSQL, again, they're open source, and there are many, many ways to install these, okay? I personally, if you're curious, if you just need a recommendation, I only have recommendation for Mac because I'm on a Mac, so I don't know on Windows. But on a Mac, I highly recommend if this is the first time you're using it, there is an install of PostgreSQL called Postgres app. Okay, so it's postgresapp.com. This is really nice because this actually is an installation of Postgres that actually gives you a nice visual user interface to actually manage it. I'll be honest, Postgres and MySQL, a lot of times when you install them, it's kind of just like a command line interface. So you're interacting with it through your terminal and stuff like that. And sometimes you don't know if it's running and you're trying to debug it and all that stuff like that. And if you're just starting out, sometimes that's really hard to understand. But if you're really comfortable with command line interface and stuff like that, you can go for it. I've used a couple of installs of Postgres. After a couple of years of dealing with it, this is my favorite way to install Postgres, actually. So it comes as an app and as a visual tool. Okay. So again, we're not going to cover that in this lecture, but you're going to want to install it. I actually have it running right here. You can see it. Here is Postgres installed. Okay. So here's my database server running. And in fact, what's really nice about Postgres is that actually allows you to run multiple versions of Postgres, the Postgres app. So I actually have version 10, version 12, and version 11 running. So here you can see I have Postgres 11 running. And in fact, there's already 3 databases running on that. Okay, so we'll get into creating those databases, but this is the first step, is just installing it. And you can see it's running. Okay, so this is ready to take connection requests and read and write requests. Okay, so that's running. Okay. All right, so that's step number 1, just installing it. Okay, step number 2, connect to the server. Okay, so we mentioned that, let me go back. We mentioned that to interact with a database, we need an application up here. Okay, and in the long run, when you're going to be a developer coding stuff against a database, in the long run, you are going to code that application up here. Okay, but until we get to that point, okay, we're going to use an already built application to connect to the database and send read and write requests. Okay, so this is just a server, and you can have multiple connections to that server. And so you could build your own application, or you can use somebody else's application. Okay, again, in the future, when you talk about building your own application, you are going to build that, and you're going to execute the read and the writes. But for now, just to demonstrate the whole SQL query language, we're actually going to use an application that somebody else built. Okay. Now, come back to this. In all those situations, this is the database server, okay? And the application that's interacting with the server, the application that is connecting to the server and sending read and write requests, that's called a database client, okay? So that's what step 2 is all about. Step 1 was setting up the server, and step 2 is we are going to use a database client application to connect to that server and send read and write requests. Okay. So the database client that we're going to use in today's lecture is called pgadmin. Okay. So it's a graphical user interface client that allows you to connect to a database, connect to a Postgres database server, and go from there. Okay. Now, one thing we should know is that this database client only works for Postgres servers. As far as I know, you cannot connect pgadmin to a MySQL server or whatever, right? But all of these applications have some database client that you can use. Okay, so once it's installed, you can then connect to that database server. Okay, so let's do that. Okay, so let's see here. All right, so here we have Postgres running. Okay, so Postgres is running. And actually, I can look at the server settings here. By default, Postgres is generally run on port 5432. Okay, So again, if you don't know what ports are, again, think of them as just almost like an address on your computer. Okay. So on your computer, you have a bunch of ports on them, and it's just like a way to say, I'm going to listen on a certain port, so you connect to that port if you want to talk to me. Okay. So Postgres, again, in general, listens on port 5432. That's my default install, so I had to run this on a different port. So I actually run this on port 5434. It's probably really hard to see that because it's so light. But I'm running this on port 5434, and it's running on my machine, okay? So anything you run on your own machine, you can specify localhost, and that will hit your machine, okay? All right, so this is running. So what I have here is, these are just previous connections, but I'm going to create a new connection. Okay, so this is my database client. This is an application that the team at Postgres built as a database client to connect to the server. Okay, so this can connect to this basically. All right, and it's kind of interesting the way they built it. It's actually a web application, so it actually runs inside a browser. But anyways, okay, so let's connect to this server. So all I have to do is right click and create a server. Okay, but creating a server basically means like you're creating a connection to a server. Okay, so I'm gonna just call this test connection, or let's just call it Postgres 11 connection. Okay, that's the name of it. And if I go to the connection, this is where I can specify how to connect to that. Okay, so where is this running? I can look up my IP address, but I'm just going to put in localhost. All right, so that is basically that is where I'm going to connect to, and then I'm going to specify the port, and the port is running on 5434. Okay, and then the username and password I set up on this, I won't say out loud, but basically. Okay, just lost connection there. So just reconnecting right now. Okay. So, sorry, where we left off is we created a connection to Postgres, and now we're connected. That was step 2. All right. Where are we now? Okay, so step 2, we're connected to the database. Step 3. Okay, now that we've actually connected to the database server, if we're going to actually operate on a database and interact with a database, we need to create the database. Okay. Now, one thing I should mention here is that this step you can actually do using the SQL query language itself. Okay. It's a little bit outside the scope of this of the talk tonight, but we're going to just use we're just going to use the graphical user interface of pgadmin to do this, okay? But do know that you don't have to use a graphical interface to do this. You can actually do this with SQL query itself, okay? All right, so I'm going to go to this here. Here's my connection. And here are my databases. And so what I'm going to do is I'm going to right click and create a database, okay? And I'm going to call this test database, okay? Or why don't we be a bit more descriptive here? Let's say it's an application that we're building, and let's say it's like a I don't know, e-commerce application where we're creating products and things like that. Okay, so I'm gonna call this e-commerce app. Okay, so now I've created the database itself. Now I have a database that I can connect to and actually start talking to. Okay. All right. So that's step 3, is creating the database. Step 4, with the database created, we are now going to connect it, connect to it using the database client. Okay, so we connected to the server, we created the database. Now we want to connect to the database itself. Okay, and again, we're going to use pgadmin to do this. Okay, so step 4, we are going to expand this. Whoops, sorry, not this one. E-commerce app. As soon as we expand it, you'll see it's now connected. Okay, that little icon going from gray to yellow means it's connected now. And so we're connected to the database now. All right, and now we're ready to actually interact with that specific database. Okay. So step 5, we're connected to the database. Let's execute some queries against that database. Okay. So let's just summarize that. 5 steps. Set up your server. connect to it with a database client, use that client to create a database, then connect to that database, and the last step, step 5, is actually executing queries against that database. Okay. So now we're ready to write queries. But how do we write queries? And this is really the crux of this lesson. So 42 minutes after the live stream started, this is really what we're getting at here, is the SQL query language. Okay. So the SQL query language is what allows us to write queries against a SQL database to read and write data, right? So that's what we talked about, right? So this is really what we're going to get at here. But if we're going to interact to read and write data, it's probably a good idea for you guys to understand how SQL databases actually store their data and how to visualize their data. Okay. And the way that SQL databases store their data, the easiest way to think of this is that basically they store all their data in tables. Okay, like literally like tables of data. You can picture like an Excel spreadsheet or a Google Sheets spreadsheet. You can picture just like tables and tables of data. That's how SQL databases operate. Okay, it's best to visualize all your data being stored in tables. And these are tables that you design. Okay, when you're designing a database, when you're a software developer who designs a database, you are going to design records of a data. You're going to design the tables and the columns that they have and the names of those columns and the names of those tables. And then you're going to populate it with data. And every row in those tables are called records. Okay, so this is how we usually talk about SQL databases. All right, so they store it in tables and every row is a record. Okay, so that's how we visualize it. So here's an example. Okay, if we were going to create, say, an e-commerce application and we're going to store users in our database, okay, this might be how one of those tables might look. Okay, we might store, an ID column to uniquely identify every user. And that ID column may be an integer. We may store the email address of every one of the users, and that would be like a string, okay? And the first name and the last name and the age, okay? So this is how we might store it, okay? And right now you can see that this table has 5 records in it, okay? So this is how you want to visualize your data. And as you program databases over your lifetime, you're going to get better and better at what to put in what tables, okay? In that same database, we may have another table called a products table, okay? So even though you have one database per application, that one database is going to have multiple tables, okay? So we may have a products table, and again, let's create an ID so we can uniquely identify every product. Every product might have a name, every product might have a price, and every product might have a serial number, okay? So these are some examples of how you might visualize your data and how you might actually construct your data. Okay, you put them into these tables. Okay, so we can create, so when we're starting off with databases, we can create these tables using the SQL language itself. Okay, but again, this talk is really about getting to the SQL queries that interact with the data. So today, again, we're just going to continue using the graphical user interface of pg-admin to do this. Okay. All right, so let's do that. Okay, so we've connected to our database. Okay, remember, this is the server running here. I'm going to close the server because just to avoid confusion. So we've already connected to the server, so I'm just going to put it in the background there. And again, this is the database client that has connected to that server, and we've connected to that specific database called the e-commerce app. Okay. Now what we're going to do is we're going to create some tables, not using the SQL query language, even though we can do that, okay? All right, so where do we create our tables? In PostgreSQL and using pg-admin, this all lies under schemas, okay? Schema is a word that you can think of meaning kind of like the specification of your tables, okay? It defines the table names, the columns, any rules around those columns, any rules around those tables, anything like that. That's the best way to think of a schema almost. It's almost like the definition of the structure of your data, okay? It's not the data itself, it's just the structure of the data. Okay, so in here, there's a whole bunch of things, but the thing we're concentrating on today is the tables, okay? So if I expand tables, you can see there's actually nothing there. That makes sense. We just created this e-commerce app database. Now we have these tables here. Okay, so let's create a new table. Okay. And I'm going to call this table users. Okay. And that users table is going to have a couple columns. Okay. So I'm going to add a column here. It's going to have an ID column called integer. Okay. So the name can be whatever you want. You can call the name whatever you want. And you can pick from the data types that PostgreSQL supports. Okay. And then I'm going to specify a name. And you can see here, we don't have things called strings, but character varying is very similar to strings. Okay. So we have the name. Actually, let's call that first name. And let's create another one called last name. Again, that would be character varying again. Create another one called email. And let's create one called age. Okay. So we have now a table that is called users and it has these fields. So I'm just going to hit save. And that actually created the table for us. Now, if you're curious, by the way, remember how I just said you can actually use SQL query language to create these tables? That's most likely what's going on in here. Like the PG admin developers created this graphical user interface for you to enter all that information and hit save. As soon as you hit save, you're actually firing off a SQL query off to the database server to create this table. Okay. So there's the users table. Let's create another one. Let's create a products table. Okay. And again, we'll give it an ID of type integer. We will give it a name of type character varying. What else do we have? We had price. Let's see what we have here in terms of price. I believe we could use double precision, like double or float, similar to that. ID, name, price. What do we have? We have serial number as well. Okay, and we'll just make that like a string. So there we go. Fire off that query, and that creates the table. Okay, so now we have the two tables that we're ready to interact with. Okay. Okay. Now, again, we are getting to really, again, 49 minutes after we started, really the crux of this lecture, which is now how do you interact with the data in those tables? Okay. When you are programming an application that interacts with a database, yes, you are going to write some code that's going to create tables. Yes, you're going to write some code that's going to alter columns, name columns, add columns, delete columns. You're going to basically write code that messes with the schema, okay? But that's not the majority of the time. The majority of the time as an application developer, you spend not modifying the schema, not modifying the structure of the database, but modifying the data that's stored in that structure, okay? And that's what the next whole bit is about. Okay. So to interact with these tables of data, to interact with the actual data that sits in there, we use SQL queries. Okay, queries is the word we use when we talk about these SQL, like these bits of SQL, these bits of SQL code that we write. They're called queries. Okay. All right. Now SQL queries really boil down to four main actions. Okay. Sometimes we call these CRUD actions. Okay. Because if you look at the first letter of those four actions, if I flip the first two, it's CRUD, C-R-U-D, create, reading, updating, deleting. But they're basically think about everything that you would ever do with data. You would either read the data, you'd either create the data, you'd either update the data or delete the data. Those are really the four main things you would do with data, right? So these are the four main actions that you would do if you're writing SQL queries. And each one of these actions has a command in SQL. Okay? So if you want to read data, you are going to write a select statement. If you're going to create data, you're going to write an insert statement. If you're going to update data, you're going to write an update statement. And if you're going to delete data, you're going to write a delete statement. Okay. All right. The select statement. Okay. So the select statement is, again, used to read data or to fetch records. Okay. If you want to get records from a table, you're going to use the select statement to get them. Okay. And here's how it looks. Okay. The way you write this, now I should mention that SQL is case insensitive, so it doesn't matter if this is uppercase or lowercase. The way I usually like to do it, I usually like to write all my kind of SQL reserved words in uppercase, and then all my like own fields and table names and all that in lowercase. But it's case insensitive, so it doesn't really matter. Okay, so select columns from table where clause. And actually, sorry, that case insensitive bit, I should mention, I don't know if that's true across all SQL databases. I know Postgres is case insensitive, but there are others that are not. And that has to do with, by the way, the commands, not the data itself. The data that you store can or can't be case insensitive. Okay, I'm babbling now. The commands themselves are case insensitive. Okay, so select columns from table where clause. So what you're going to do here is you're going to say, I want the ID column, the name column, and the email column from the table called users. Okay, and optionally you can specify a where clause, which basically says, I want to narrow what you give me back. Okay, so I could say something like select the name and the ID from the users table where the age is above 20 or something like that. Okay, so you're only giving the records that meet a certain clause, and we call that the where clause. Okay, and again, that's optional. So here's a bunch of examples of that. One of the very common things you'll do in terms of the columns that you specify is use star. What star means is basically just select all the columns. Okay, so the very first statement is basically select all the columns from the users table. The second one is select all the columns from the users table, but only return the rows where the ID is equal to 4. And in our case, that will only be one row, right? Like as long as we keep our IDs unique, that'll only be one row. You could select very specific columns. So I could say, I only want the ID column and the email column from the users table. I could only want the first name or the last name from the users table. I could use things like ranges. I could say, give me all the columns from the products table, but only where the records have a price that's greater than $1,000, something like that, right? And I could also do, select one column from the table. Okay, so that's a select. Okay, the second one is the insert statement. Okay, and the reason I don't want to show you a demo yet is because if you think about it, the select is meant to fetch records. If we went to fetch records right now, we have no records in our database, so it would be empty. Actually, why don't I show you? Okay, so if I go back to my database, how do I actually execute queries against this database? If I right click and go to query tool, here we are. Now we're connected to the database, ready to execute some queries. So I could do select all the columns, from the users table. Okay. And this is going to return all the columns and all the rows from that database. Okay. Sorry, from that table. Okay, I can hit this play button up here to execute it. Okay, and you can see it returned all the columns, but there's no data here. There's no rows came back, right? So that makes sense because we haven't inserted anything into this yet. Okay, but that's how it would look. But actually, just as a demonstration, I can show you. I could say select ID and first name and execute that. And just the ID and the first name came back. But now again, there's no data in those rows, those columns. Sorry, there's no rows of data in this table. Okay, so let's go to the next one and actually get some data inside here. Okay. So the second statement that we're going to learn is the insert statement. So this is used to create records in your tables. Okay. So the way you do this is you say insert into table. So insert into products or insert into users. And then you do an open parenthesis and a close parenthesis. And inside here, you specify the columns that you're going to provide data for. So when you create a record, you don't have to specify all the columns. You don't have to have data for all the columns. Okay. You can just say, I want to just insert a record and just specify the ID and the name, for example. Okay. So you specify the list of columns here, and then you write values, and then you provide the values in here. And the key to this is that these are comma separated values and they have to line up. So if you're saying insert into table ID, comma name, for values, you want to specify the ID first and then the name after that. Okay. So here's an example. I'm going to insert into the users table a record where I'm only going to specify the ID and the email address. And the values that I'm going to insert in there are the number 6 and user6@example.com. Okay. Here's another example. Insert into products, ID, name, and price, a record with the value of 7 for the ID, MacBook Air for the name, and $999.99 for the price. Okay. Actually, this is a little bit wrong. I'm specifying a string here, so there shouldn't be those quotations around that. So let me just quickly fix that. Okay, perfect. All right. So what do we got? Let's try this out. Okay, so I just did a select ID and first name from users. There's nothing in there. So why don't we actually insert a record into this? Okay, so let's do an insert into the table users. Okay, and I'm going to specify the ID, the first name, the last name, and the email. Okay, and the values I'm going to provide are ID1, Casey, Lee, and then Casey at example.com. Okay, so I'll execute that. Okay, and you see the query successfully returned. Okay, so now that should be inside that table. Okay, so now if I do a select from users, so I'll do select star from users, hit play, you'll see the record is right there. Okay, so let's do another one. Let's do insert into users. Say the ID, say just the email address and the age. Values, ID2. We'll say the email is user2 at example.com. And the age, let's say, is 23. Okay, execute that. So that inserted successfully. Now let's do a select star from users. Again, not case sensitive, but just my own habits. Okay, there we go. And there's the second record. Okay. Now, in fact, now that we have two records in here, we can actually see a little bit the power of the where clause. So I could say, okay, select all the columns from users, but only the records where the ID is equal to 2. So that should only return this record right here. So let's see what happens. If I hit play, there we go. It only returns that record. Okay. And if I take off the where clause, it just selects all the records. And in this case, all the columns from all those records. Okay. So there we go. Why don't we try the products? So if I do a select star from products right now, there's nothing in that table, right? So I shouldn't get anything back. Okay, so nothing came back. But let's insert some stuff into here. So insert into products. And I'm going to specify the ID, say the name and the price, and the serial number. We'll specify everything. Okay, and the values we're going to provide, ID1. Let's say MacBook Air. And let's say the price is $999.99. And the serial number, let's say, is MBA13. So insert that. Okay. And let's insert another one while we're here. I want to erase this all. I'll just insert another one. So value 2, let's say MacBook Pro. And let's say it's $1299.99. And we'll call this MPP 13. Okay, so hit play. All right. So there we go. We've inserted two records. So now if I do a select star from products, you can see the two rows come back. Okay. And again, I can do something like this, where the price is greater than $700, let's say. Okay. And that returns both the records because they're both more than $700. But I could say also more than $1,000. And in that case, only the MacBook Pro comes back. Okay. All right. So that's how insert works. Next, update. Okay. So update is used to update existing records. Okay. So if you have a record in there, you can update some value of that record. Okay. And so the way this works is you say update the table name and set a certain column equal to the value that you want to set it at, and apply this to any record where the clause is true. Okay. Now, one thing to be very, very careful about the next two statements, the update and the delete, which we'll show next, is if you do not specify a where clause, you are applying this to every record in that table. Okay, so you have to be very careful of that, okay? So it's really, I shouldn't say it's really rare, but it's definitely more on the rare side that you do an update or a delete statement without a where clause, okay? Because that will affect every record in the table, okay? So let's take a look at this update statement. Okay. So let's just take a look at the records we have in the products database, or products table, sorry. So if I do a select star from products and hit play, you'll see I have multiple rows here, okay? And now let's say, oh, you know what? I actually typed in the name of this wrong. This should be MacBook Pro 13 inch. So let's say I want to update that. Okay. So I only want to update this record. I don't want to update both of them. Okay. So kind of a good habit when you do update statements is actually write your where clause first before you write the rest of your update statement, because it'll help you kind of zone in and only affect that record, and you won't accidentally update everything. Okay. So a good way to zero in on that is write your select statement with a where clause first and then replace the select statement. Okay. So here I have select star from products, and let's say I want to target this record here. Okay. ID2. Just to make sure I'm not missing anything, I'll type where ID is equal to 2 and I'll run that. Okay, that's great. So that only returns that record back. So now I know this where clause is only going to target this record here. So I'm going to leave that where clause here and just replace this with the actual update statement now. So update the table name, so products, set name equal to MacBook Pro 13. Okay. So what this is going to do is it's going to go to the products table, and any record that passes this where clause, ID equals 2, it's going to set the name equal to MacBook Pro 13. Okay. So I'm going to run that. Okay, so that returned successfully. So now if I do a select star from products, you'll see now it's been updated to MacBook Pro 13. Okay. Here's the reason why it's really good practice to do that, because if you were to write update products, say set price equal to $13.99, okay, because you want to set the price of the MacBook Pro, and you haven't written your where clause and you accidentally hit the play button or a shortcut. By the way, on this application, F5 is a shortcut for that. If I accidentally hit that, that's now actually affected all the rows in the products table. So if I do a select star now from products, you'll see it affected all of them. Okay, and we don't want that. So you can imagine if you had a table of like 1,000 users and you had every one of their email addresses, and you accidentally wrote an update statement where you said update users set email to this, and you forgot your where clause, it would actually basically wipe out all the email addresses. So update statements can be very, very dangerous that way. Okay, so let's set that back to what it was. So what I'm going to do is I'm going to do a update the products table. Actually, I'm avoiding my own advice here. Let me do my own advice. Okay, so let's select star from products, and let's do the where clause first. So where ID is equal to 1. Let's run that. Okay, that is the row that I want to target. So now I know my where clause is good. So let's get rid of this in the beginning. So update products set price equal to $9.99. Okay, play that. Now if I do a select star from products, we are good to go. Okay, there it is. All right, so we're good on that. So that is the update statement. And the last one we're going to do is the delete statement. So the delete statement, again, same consequence here. Be very careful to write your where clause first. Otherwise, you're going to delete all the records from the table. So you're going to say delete from the table where a certain clause is true. Okay, so you can say delete from users where the ID is equal to that, or delete from products where the name is equal to that, or something like that. Okay, so this is a kind of a wild card way. If you want to look at a string, you use the word like rather than equals, and these are wild cards. So you can say anything that contains the word MacBook basically would work for there. Okay, so let's take a look at that. So let's say here I have a couple products in here. So let's say I insert another record. So let's say I insert into products, and we'll do an ID, name, price, serial number, values. Okay, so we'll insert 3, say an iPhone 11 Pro. Let's say the price $12.99, and let's say the serial number is IPLL or 11P. Okay, so we got that. And let's put in another one, say iPhone 11 Pro Max. And let's say that's like $13.99, serial number like that. Okay, so let's take a look at our thing right here. Okay, so what I'm going to do, by the way, is I'm going to show you a little trick here if you don't want to keep erasing your queries and rerunning your queries, especially in pgadmin. What you have here is you're executing queries, and whenever you hit the play button, it actually executes everything that's in this window. One thing you can do, but again, I do caution you, is that you can highlight just what you want to execute. Okay, so if I have just this highlighted, it'll ignore this actually up here. The reason I caution you is that if you don't have a good handle on this and you accidentally don't have that selected, you accidentally click off of it, it's going to execute everything and you might not want to execute everything. Okay. So just to keep it safe, again, as an introductory lecture, I'm actually going to delete these and just run whatever in here. So select star from products. Okay, great. So we have ID1 here, ID2, ID3, ID4, 2 MacBooks and iPhones. Okay, so let's do deletes now. Okay. So what I can do is I can do now a delete from, okay. Now again, I'm not following my good practice. Why don't we target the rows that we want to do first? Okay, so let's do select star from products, where, and I'm going to do a where clause on the name. Okay, so I'm going to say where name is like, and then I'm going to use wildcards, iPhone. Okay, so what this is saying is that any record where the name contains the word iPhone. So you have a wildcard at the beginning and wildcard at the end. Okay, so it basically says 0 or more any character before it, 0 or more any character after it. Okay, hit play. Okay, great. So that targets these 2 rows. Okay, so it's only going to affect these 2 rows. So now I'm going to delete what's before the where clause and do delete from products. Hit play. Okay, so those are deleted now. So if I do select star from products, there you go. We're left with just those 2. Okay. So there you go. Those are the 4 actions that you take in SQL. Okay. So insert, create, select, create. Oh my God. Select, insert, update, and delete. Okay. And that is how you store data in the database. Okay. And again, it's persistent. All right. SQL databases are generally persistent. So when you shut down your computer and you start it up again, you can fire up your database client and you can grab that data back and so on and so forth. Okay. So that is what SQL is all about. Okay. So one thing you should know is that the things that I just taught you are just the beginning. These SQL queries can get so big and so complex, and there's a lot more you can do with SQL queries. You can do things like sorting. You can do other complex things to filter the where clause. You can actually select data from multiple tables. We call these joins, okay? And there's really complex things you can do with joins. There's a lot of crazy things you can do with SQL. And what I've just shown you is just the beginning to basically deal with the data that you're dealing with, okay? So maybe next time, depending on what the audience wants, we might do some more advanced or intermediate SQL at that point. Okay. Okay. So you might be wondering now. Okay, well that's great. Okay, I use pgadmin and I'm able to insert data and I'm able to update data and delete data and stuff like that. But how exactly do I get my application to do that? Okay. So, I mean, you talk about like your applications as like you want to be writing data from your application into these databases. Okay. And how do you do that? Right. So the best way to view that is pgadmin is one database client and your application that you're building is another database client. Okay. So these are 2 database clients that can be connected to the database. Okay. And when you write an application, you are writing an application that is then going to it's going to connect to a SQL database, and it's going to send queries to it. Okay. So here's your application, and you want it to talk to a database. Okay. So up until now, the database client that we've been using is pgadmin. Okay. Sorry, that should be pgadmin. Okay. But what about if you want to build your own? So if you want to build your own, you're going to build your own database client. Just like the team at Postgres created a database client called pgadmin, you're going to build your own, okay, which will be your application. So this could be a Java application, a web application, a mobile application, whatever. And in it, you're going to write some code to connect to a database. Okay, so connect to a database server and connect to the database itself and execute select statements, insert statements, and all these things. Okay. And so what your code will do is it'll get intelligent. Rather than hand coding a select star from products where da 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 da, your code will construct that SQL statement, right? It'll say, okay, select star from users where ID is equal to this person's ID, or where email is equal to this person's email, whatever, okay? And that's where this is all leading to, okay? Is you're going to write code that connects to a database and executes it, okay? Now, because this is such a common thing to do, okay, it's very common to write an application that talks to a database. There are libraries out there that help you do this, okay? And a lot of times, these are called database adapters or database drivers, okay? So these are libraries that help you connect to databases and execute SQL code, okay? So a database adapter or a driver is basically a library that allows you to connect to a database and execute SQL queries, okay? If you want to get really concrete about this, if you're using an object-oriented programming language, this is basically a set of classes and methods that help you execute and connect to a database. Connect to a database and execute SQL queries. So Java has a bunch of these database adapters and drivers called JDBC drivers, okay? Java Database Connection Drivers is what they're called, okay? Ruby on Rails has its own adapters, and they're distributed as gems. So you install a gem called PG, and that's your database adapter to connect to a Postgres database and interact with it. Okay, and they'll provide you methods, so you can literally say like connect to this database and then execute this query and things like that. Okay, and then so that basically acts as your bridge between your database and your Java application. Now, if you go back to my last week's lecture, we talked a little bit about ORMs, and what ORMs are is a smart way to then use the database adapter to map your objects to your database records. Okay. So that is where this is all heading. But to get there, you have to understand how SQL queries work in the first place. So if you're brand new to SQL queries, the best thing I recommend you do is you create a test database and you just start executing queries against it to see how it works. Okay. Send some select statements, send some insert statements, and yada, yada, yada. Once you get really comfortable with that, then you're ready to get to this part where you actually have code that executes and builds those queries for you. Okay. Again, maybe next time. Maybe we'll build that from scratch. We'll see. Okay, so that is it. That is your introduction to SQL. Hopefully those of you guys who don't know SQL were able to get something out of that, and hopefully you guys will be able to try that out. And again, happy to continue talking about SQL in future YouTube live sessions. It's totally up to you guys at that point. So, okay. So, all right. So these things are usually about an hour and a half. So we got about 15 minutes left here. Usually at this point I open up things to a Q&A. So see, my good friend Dave is online. He definitely knows all of this stuff. So I'm sure he does not have questions about that specifically. But again, those of you who are new to this, this is basically my day-to-day is on the left. So Ruby on Rails, React, HTML, CSS, JavaScript, PostgreSQL, React Native, Expo, Heroku, GitHub, Bitbucket, Adobe Creative Suite. And on the right side is kind of stuff that I've dabbled with in the past. My original training was in Java, moved to JSP, which was my kind of first real foray into web development. Did some ASP.NET, specifically C#.NET actually. Have done some Objective-C, Swift, and a really tiny bit of Node.js. So if you guys have any questions, feel free to ask them. I'm definitely around to take some questions. But if not, if you guys are heading off, again, I really want to thank you guys for tuning in. And again, don't forget to subscribe. Don't forget to hit that bell icon to get notified when I do these lectures in the future. And again, if you ever miss any of these, don't worry, they will be going up live afterwards. So, okay. All right. Only have 2 people watching right now. So don't know if we have any questions. Whoever else is watching, do you have any questions? I'm just going to kind of sit here awkwardly for a little bit in case you guys do have any questions. But if not, again, That's pretty much it for today. So Dave Chapman, nice job, good intro, to SQL. Yeah, appreciate it, Dave, and I appreciate you tuning in. Yeah, I mean, SQL is definitely one of these things that when I was in undergrad, it was the strangest thing about databases is I never understood the value of databases, because the majority of what I interacted with as a kid and going through high school and stuff were programs that did not use a database, right? If you think about the majority of programs that I used growing up were things like Microsoft Word, like the Adobe Suite, what else? Notepad, any like things like this, and the persistent storage was always a file. So when I was going through undergrad, I was always really eager to like, when are they going to teach us how to write to a file? I never really understood the whole like big deal about databases. And in fact, when I found out what databases were, I was like, what? There's a whole course dedicated to just storing stuff in tables and manipulating tables and stuff like that. It was definitely something that was very like I just couldn't get it. I couldn't understand it. And then it wasn't until a lot later that I realized that a lot of these big players, and a lot of these big applications, and especially with the move to a lot of this like web-based stuff, um, it's very it was very interesting for me to realize that all these things are driven by databases, and databases run a massive chunk of the world's applications. So that was kind of interesting. Have you played around with GraphQL at all? Any thoughts on comparison with SQL? Okay, I have not played around with GraphQL at all. For those who don't know what GraphQL is, so as far as I understand, GraphQL is so when you deal with web applications, a lot of times what you're dealing with is you're dealing with the browser requesting data from a server. And when you're requesting data from a server, a lot of times that data comes back as some formatted data. So two most common ways to format the data is either JSON or XML. And as far as I understand, GraphQL is a way to almost dictate what you're going to get back from the server. So traditionally, before things like GraphQL existed, whoever coded the server, the web server, would say, okay, if you request, information about a user, I'm going to dictate what you get back. You're going to get back the ID, the email, this and all that stuff like that, right? It was typically the web application, the application server programmer, or whoever's coding the server side basically would dictate what was being sent back. And this caused a lot of issues because either one, as a full stack developer, if you were coding the client side code, you might have to then say, oh shoot, that piece of data that I needed on the server is not being sent back by the server. So now I have to go change the server code. Worse than that is if your team is separated. If your team is actually big enough or disciplined enough or whatever, for whatever reason, separated into client-side programmers and server-side programmers, now you have teams that are waiting on each other, right? So if the client side is like, oh, I need more than just the ID and the email of the user, I need their age and their name and stuff like that. Well, then they have to go make a request to the server side, and then the server programmers tell them, oh, okay, well, put that into the backlog. We won't get to it till next week. And there's a lot of synchronization issues there in terms of like workflow. So that's really bad. And then third is you have this idea of APIs, right? So sometimes APIs, it's not even in the same company. You have one company, and they're talking to the code of another company, and they need certain pieces of data, and they can't get the data that they want. And sometimes you have the opposite problem where you're getting too much data. It's like, well, all I need is the ID of the user. I don't need all this other stuff that you're sending back to me or whatever, right? So there's a lot of issues with leaving what gets returned to the client to the server developers. So it's my understanding, and hopefully I'm not way off on this, but it's my understanding that GraphQL is trying to solve that problem. So GraphQL is a way to basically allow the client to specify exactly what they want back in terms of their data. Now, before you ask this question, Dave, I actually didn't think about it at all in that way. Like literally what I'm talking about right now it just kind of like dawned on me when you mentioned its comparison to SQL. Yeah, that makes a lot of sense. That it's kind of like SQL in the sense that you have a server that potentially could give you all the data that you want, but you're specifying only the data that you need in the way that you want. So, yeah, I've really never thought about it that way until like literally you just asked that question. So that's a pretty interesting way to look at it. And as we move towards servers that kind of get, to be honest, lighter and dumber, and we start to move more of the application logic into the client, it makes more and more sense that to have things like GraphQL, because really then what happens is like all our application logic can really start to live in the client. And really it just seems like what we're doing is we're just shifting everything, right? It's like in a full stack, right? We have like client code, server code, database code, right? And so as we get to more client rich applications, the server code is moving more up to the client, and as a result maybe the database logic now is moving more up to the server, right? Or at least being kind of almost transparent through all the way up to the top. So yeah, very very interesting. I never thought of it that way. I haven't played with GraphQL, so I could be way off on this, but if that's really what it does, then yeah, it's an interesting shift that everything is kind of moving up. And I mean, we it sounds like that's what we're seeing with like a lot of these kind of servers as a service, like Firebase and stuff like that anyways, right? Where it's like it's very again, the server in the backend code is very very loose, or not loose, wrong word, very light, you know, and logic, and they're getting lighter and lighter, and more of the logic being moved to the client. So I think in that situation where we're moving more and more stuff to the client, I think it makes a lot of sense. In my personal experience, because most of the people that I deal with are full stack developers and we're working on apps that are relatively small and relatively small teams, I can't say from experience that I instantly recognize the benefit. But just theorizing that seems like a very interesting benefit of that. So, Dave, I don't know if you yourself have dealt with GraphQL and your experience with that, but definitely happy to have your thoughts. Speaking of, we have had a request on this live show to bring in other people to interview. I have interviewed Dave on my podcast. So if you check out my podcast, it's called Casey Talks to People. Definitely listen to that. He has a lot of really interesting insights. Dave is this guy that I've always quoted as, being like the best software engineer I've ever met. And I think that's still true to this day. Very interesting insights on software engineering. Dave, maybe I'll get you on this show. I just figured out the other day how to do a Skype call on OBS and do a live stream, and so everybody will be able to hear both of us. So maybe we'll have you on the show sometime to talk about some concepts or whatever. So would be happy to have you on. So the nice thing too is that GraphQL is really just an adapter. It isn't a database. So you can still have a SQL database, but just a single GraphQL endpoint to serve data alongside typical REST. Right. Yeah, that's a very good point. So GraphQL, I should mention, it is a layer above the entire server, right? So running on your server, you might have server code and backend SQL database, but you have this layer of GraphQL above it. So you kind of have it living there. So a lot of stuff can power the data that's going up to GraphQL. It doesn't, it's just adapting down to whatever's below, right? And if it happens to be server code and a SQL database, that could be it. It could be anything else below, which is very cool. So definitely very cool on that. Cool. Great discussion there. Any other questions? Any other? All right. Okay, I'm gonna start wrapping things up. But how about comparison with NoSQL? Any experience with that? That is a great question. Perhaps based on the last time I had lunch with Dave, this might be seeded a little bit. How about comparison to NoSQL? Okay, yeah. So NoSQL. So I've had a really interesting experience with NoSQL. when I first came across NoSQL, I interpreted it as not SQL. Okay, as in like it's just like it's a database that doesn't involve SQL queries. And then I read some article that said, okay, NoSQL stands for not only SQL. So then I started to get the idea that NoSQL meant, oh, it's SQL plus a whole bunch of other stuff, which is not really true. It really is my first instinct, at least my experience with NoSQL. It's my first instinct. My first instinct being that it's a completely different way to store and interact with data. Okay. SQL databases are very much, again, tables of data, and they use a SQL query language. What a NoSQL database is, at least in my experience, is really a way simpler way. I shouldn't say simpler. It's a very different way to store your data. Okay, and the way that NoSQL stores its data is actually as a bunch of key value pairs. Okay, so actually, let me bring this up here. So whereas in SQL, okay, so we have this database here, right, with two MacBook laptops here with the data in here. In a NoSQL database, you might have something that looks like this. So you may have, and again, it's a bunch of key value pairs. So you can kind of look at this as, okay, so we have this root key value pair. So it's a root. And inside here, we have more key value pairs. So the key is, say, products. And the value is an array. Okay. And then we may have users. And the value is an array. Okay. And then inside that array, we might have again, one product that has ID 1, and then name, MacBook Air, price $9.99, and so on. And then we'll have, another one of these. Now, for those of you who are familiar with JavaScript, you may recognize this. This is called JavaScript Object Notation, or JSON. But a lot of NoSQL databases, it's easiest to view them as kind of like JSON data, key value pairs, basically, right? Okay, so this is what a NoSQL database looks like. Now, one thing that's interesting about NoSQL databases is you could have data that looks like this. So you could have let me see here. So in this situation, what you have is you have 3 products, and 2 of them have the same key value pairs, and the third one doesn't. And this is the really interesting about NoSQL, is that NoSQL has no idea of what we call schema. Like what I talked about, there's no structure to what every one of your records has. They don't really call them records in NoSQL, but if we're kind of using SQL as a comparison. So here we have ID, we have name, we have price, but it doesn't really enforce that on that. And it's really up to the application to be either smart enough to handle that or to deal with that. So one of the interesting things about this is it makes it really easy to just get going, right? You just store data. You don't have to think about all the columns that you need, and you don't need to modify anything. And if in the future you decide that you want to add a field to it, it's not like you have to modify any schema, because there is no schema. So on one hand, it's really flexible that way. But on the other hand, what ends up happening here is you have to then be really smart in your programming not to do things like assume that products have an ID, right? So there's a very different mentality there when it comes to like how you store your data and how you deal with your data. Again, you can't take for granted that these things are going to come back or whatever. But again, it makes it really flexible, because at any given point on the fly, you could add a field if you want, right? So let's say, 5 weeks from now, you decide, oh, there's going to be a promo code attached to all the products, right? You could just add that in there, and the ones that don't have it, you don't have to populate them or anything like that. You can just add them as we're going forward, and then your application code can just say, oh, does this product have a promo code or not, right? So you can do things like that. So that's the interesting thing about SQL, NoSQL databases, is you don't deal with schema. But I actually think what is most interesting about NoSQL is not really the internal structure and not the implementation details. The biggest thing I think that is really interesting about NoSQL that, by the way, SQL developers can learn from, as I am. I'm actually taking this philosophy from NoSQL and applying it to SQL. It's this idea, like the whole reason NoSQL, as far as I know, the reason NoSQL gained popularity and is really taking off is really this idea of denormalization. So when you become a pretty advanced SQL developer, you start to learn that normalization is really a big thing in the game. Which basically means that normalization is the idea that you generally only store your data in one place. Okay. So if you had the user's name that you wanted to display on, say, a comment they left, or let's say a picture that they uploaded, you want to store the person's name. The person's name would only be stored in one place in the database. And if you ever need that person's name, you reference that place in the database and you grab that name. Okay, and that's what normalization is. Normalization is the idea that you only store your data in one place. NoSQL databases really advocate for the idea of denormalizing your data, and denormalizing your data in the interest of performance and I don't know if I'd go as far to say user experience, but basically performance. Okay, so one of the big problems that exists with SQL databases that has to do with normalization is getting the data that you need sometimes is very expensive, i.e. it takes a long time to get the data that you need, or it leads to very complex queries. Okay. So for example, if I had this database here and let's say I had a user ID 1 and the name Casey here. Okay. If my database was normalized, I might store something like this. Okay. So this product was created by the user with the ID 1. Okay, and this one was created by user ID 1. Okay, and this one was created by user ID 1. Now, let's say I wanted to show these products and show who created them, the name of that person. Well, what I'd have to do is I'd have to make two queries, right? I would have to query the product that says, oh, created by user ID 1, and then I'd have to make another query to go find that user and then find that name and then display that name. Now, in SQL, there are ways to make this a bit more efficient using join queries and stuff like that. But the problem with that is that can get very complex and like your queries can get really big and it gets really ugly and it gets really crazy. So what a lot of NoSQL databases advocate for is this idea of denormalizing your data. In other words, not storing your data only in one place and optimizing it for how you might use it. Okay, so for example, so in this case, I may say, okay, I'm going to store the created by user ID, but as well, I'm going to store the created by username. Okay, and I'm just going to store it in there. Now what happens is if I make a query for my products, the name is right there. Okay, so this is really handy because if I need to store the product, I don't need to make a subsequent query to get the name, right? But then you might be asking, well, what happens if I change the name? What if I change this to Casey Lee? Well, now I have to go through every single product and update every single created by username. Right? That seems very cumbersome. And that's one of the advantages of normalizing your data. In SQL, one of the reasons we normalize our data is that we can update only in one place, right? We don't have to go update everything. But if you look at those two scenarios, normalizing data is optimized for updates and writes and deletes and stuff like that. Denormalized data, okay, is optimized for reads, right? So when we're reading this data, right, this is a better structure. But if we're updating the data, the other structure is better. So then you weigh this against how your application is actually used. If you take a application like Amazon, okay, so you have a product page in Amazon, and it was created by Casey, okay? The number of times that page is viewed by a person and view who created it is probably way higher than the number of times that the user Casey changes their name. Like the number of times that page is viewed is maybe in the neighborhood of like 1 million a day. It could be like really high. But the number of times that someone changes their name could be maybe once a year, once every, like maybe never, right? So why would we be optimizing our data for writes versus reads when our application is read a lot more than it's written? So that's a really interesting concept that I learned through learning NoSQL. I'm by no means a NoSQL expert. There's still a lot of things I struggle with NoSQL, and I'm still not fully convinced it's the way to go. Well, sorry, I am convinced of the benefits. I just don't know how to use it enough to go that way. Um, but it's a very interesting concept, this idea of denormalizing. And so what I am doing in the meantime is this idea of denormalizing the data in a SQL database, because all it takes to denormalize data in a SQL database is literally duplicate that data, right? Like there's nothing stopping you from putting a created by username in a SQL database, right? There's nothing stopping you from doing that. So that's what I've been doing in some of my apps recently, where it's like, oh, we are loading like 1,000 entries, and for each one of those 1,000 entries, the join that I need to do to find all the extra data is really complex, or I can't figure it out, or whatever, or it's just taking too long to figure out. So, or even after I figure it out, the join is just taking too long to process. So why don't I just store that directly on the record, and it makes this like 10 times easier, right? So that's a really really interesting concept with NoSQL databases. And again, there are definitely a lot of things that I'm very curious how people solve, because it seems like it's optimized for reads, but that's because maybe your user interface is a certain way. Another thing they talk about is optimizing for the user interface. But I always wonder, well, what if your user interface changes? Like it's weird to bind your data structure to your user interface, right? That's a little strange to me. So yeah, very very interesting concept. I'm still learning it, and I'm still kind of going through it. The biggest reason I use NoSQL today is because of Firebase. Firebase is an incredible set of like libraries and tools to build applications, and they happen to use NoSQL in the back end. So I'm kind of stuck in that, and that's why I learned it that way. So there's still a lot of things that I'm very struggling a lot to figure out in SQL, because again, your mind really has to change. Like your data modeling mind really changes. So, but yeah, I think it's definitely worth exploring in this day and age, especially because sometimes people use a mixture of the two for different reasons, right? I know Redis, I believe, is a key value store, NoSQL. And I know in a lot of Rails apps, you use SQL as your main backend, but you use Redis for things like queue management and stuff like that. So very cool, very cool. Okay, so that's NoSQL. Again, any questions? Definitely if there's any more, I'm still happy to chat. But I'll start wrapping things up, and if another question comes in, maybe we'll do another question. But thanks, honestly. It looks like there's 2 people watching, so thanks for the 2 people who tuned in. We declined a little bit over the last 2 weeks, but I still plan to do this every Thursday. Dave, I'd love to have you on sometime. Well, maybe we'll get you on a Skype call at some point to talk about some topics. Would love to hear that from you. And for everyone else out there who's watching, thank you so much for supporting this channel and supporting this. I'm having a lot of fun getting into live streaming. It's really fun. And I feel like, teaching these software concepts, it's a really nice way to do it. I thought in the past that I would just do some pre-recorded videos. The nice thing about live streaming is I can spend a couple hours doing this, and then I just shut it down and it's live, and then I'm good to go. I don't have to worry about editing or anything like that. It's a really, really easy way for me to keep this maintainable. It's kind of like when I did the podcast, right? The podcast was something that was easy. I just recorded, did basic editing, and set it up, and it was all good. So definitely want to thank everybody for tuning in. Don't forget to subscribe. Don't forget to hit the bell icon to get notified when I'm going to be next. And don't forget to spread the word. Again, any software engineers, computer scientists, developers, whatever you call them, or anybody who's interested in learning this stuff, very, very happy to have them on board. Definitely want to welcome a wide range of skill levels, and definitely looking for suggestions from you guys in terms of what you want to see. So either send me a message on Twitter, message in the live chat, whatever way you can get a hold of me. Definitely get a hold of me. And that'll be good. So anyways, thanks for guys for spending your hour and a half or so Thursday night self-isolated and staying safe and all that stuff that everyone's saying right now. But thanks for spending the night with me. Really happy to have you guys on board. Thanks for tuning in. We will see you guys next Thursday at 8 p.m. I have no idea what the topic's going to be. I was thinking of maybe doing a live coding session, a live HTML CSS coding session. I thought what I would do is I would take some website and try to replicate it using HTML and CSS and see what I could come up with. So We'll definitely chat then next Thursday, 8 p.m. Spread the word. Thanks, guys. We'll see you later.